Newton's notions of space. Newton's notions of space. Of space. Absolute space in its own nature. Absolute space. Absolute space in its own nature. In its own nature. Absolute space in its own nature without relation to anything. Without relation to anything external remains always similar and immovable according to immovable. That means Newton's notions of space. The definition of Newton's notions of space: absolute space in its own nature, without relation to anything external, remains always similar and immovable. According to Newton's main classical properties of space are: space is three-dimensional. According to Newton's main classical properties of space is three-dimensional. Space is three-dimensional. That means the concept of space and time is fundamental to the study of mechanics. All objects occupy space. All objects. That means you are known about this pen. All objects occupy space and have a length, a breadth, and a height. Space is therefore three-dimensional. That means x-axis, y-axis, and that is z-axis. This is the three-dimensional. That is x-axis, y-axis, and z-axis. This is why the position of a point can be specified completely by the three-dimensional coordinate x, y, z. Coordinate x, y, z are theta, phi. The second number of Newton's notions of space lies. Space is flat. Just a 1 minute. You wait just a 1 minute. Space is flat. That means space is flat. Its position Euclidean flatness. This means that the shortest distance between any point. In space is straight line. If we take 3 points in space to form a triangle, the sum of angle is equal to pi. The sum of angle equal to pi. equal to pi. The sum of angle equal to pi. If it is a right angle triangle, then if it is a right angle triangle, that means one angle is 90 degree. That means one angle is 90 degree. Right angle triangle, then the three sides are related by Pythagoras theorem. That means hypotenuse square equal to base square plus altitude square. Hypotenuse square equal to base square plus altitude square. If hypotenuse is A, base is B, and altitude is C, then hypotenuse A square equal to base B square plus C square. 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 However, according to a latest theory, space is not exactly flat. Space is not exactly flat, but somewhat curved. The departure from flatness is very small. Departure flatness is very small and can be ignored in the study of classical mechanics. The third number of space notions lies space is homogeneous. Third number, space is homogeneous. Space is homogeneous. That means, in other words, space is everywhere alike. Homogeneity of free space, or space in which field and forces are absent, or space in which forces and field are absent. Means translational invariance of its properties. The result of an experiment is not altered due to linear displacement of the coordinate system. The fourth number is space is isotropic. Space is isotropic. Space is isotropic. It means that if we consider a point O, sorry, you wait just 1 minute. Look at this carefully. It means that if we consider a point O and we move from the point, it means that if we consider a point O in space and we move from this point in any direction, you let this is the x-axis and this is the y-axis and this is the z-axis. Then we move from this point in any direction. The properties are the same. There is nothing to distinguish one direction from the other. In other words, there is no preferred direction in space, or one direction is as good as any other direction. It means space is isotropic, means if you move any direction, there is no difference between moving direction. Distinction between homogeneity and isotropy. distinction between distinction between homogeneity and isotropic. Homogeneity and isotropic. The homogeneity of space means translational invariance of the properties of space. If we consider two coordinate system S and S dash, S and S dash, you let this is the x-axis, y-axis and z-axis, and this is the S vector and y dash, x dash and z dash. This is the S dash, S and S dash. If we consider two coordinate system S and S dash displaced with respect to one another, I shown in the figure, then an experiment performed in system S dash will give exactly the same result in the system S will give exactly same results in the system S dash. On the other hand, isotropy means rotational invariance of free space. Isotropic means rotational invariance of free space. Thus, if we have two coordinate system S and S dash rotating with respect to one another, then again an experiment performed in system S dash will give exactly the same result in S. Okay, thanking you.